I'm Sai Krishna, roll number of 24 BQ 1004 and 94. And today I'm going to explain about the MOSFETs in the EDC subject. The MOSFET, the full form of MOSFET is metal oxide semiconductor field effect transistor. And this MOSFET is more important in the electronic devices and the circuits and in simple amplifiers, complex multiplexers, and all those. And these MOSFETs are very important in these subjects. And now I'm going to explain about the introduction of MOSFET and working of MOSFET and all. Let us see one by one. Slide. Introduction of MOSFET. MOSFET stands for metal oxide field effective transistor. It is a voltage controller device and used for amplification and switching. And generally, these MOSFETs are having only three types. First one is three types of terminals, and first one is gate, and second one is drain, and third one is source. Current flows in this MOSFET. The current flows controlled by gate. I mean current flows from drain to source and it is controlled by gate. Widely used in IC amplifiers and digital circuits. Digital circuits, because of the input gate is extremely small MOSFET, the MOSFET consumes very low power and integrated circuits and digital circuits. And in the simple terms, a small voltage at the gate can control a large current and current on the device and which MOSFETs they are used in amplification. And this is about the introduction of MOSFET. Now I am going to explain about the construction of MOSFET. Now we will see the construction of MOSFET. Construction of MOSFET consists of a semiconductor substrate, usually silicon. And we construct a MOSFET and first we need of substrate and that is p-type substrate and gate SiO2. Gate is insulated in the channel thin layer oxide SiO2 and SiO2 is on the p-type substrate and source and drain are heavily doped and n-type or p-type and the layer provides a high impedance. And types of substrates are n-channel MOSFET. We have two types of substrates, that is n-channel MOSFET and p-channel MOSFET. The gate controls the channel formation and means electric charge and since oxide prevents the current flow and input impedance is extremely high. This makes the MOSFET highly efficient and leads to IC fabrication. And these MOSFETs are important. And this is about the construction. We have a p-type substrate and we have two n-type doped molecules and N and P and SiO2 layer on the gate. And we are having two types of MOSFET, that is n-channel MOSFET and p-channel MOSFET. Now we will see that working principle of a MOSFET. The working principle of a MOSFET is based upon the electric field charge. And when a voltage is applied on the gate, the electric field across the oxide layer, the electric field influences the charge carriers in the semiconductor beneath. When we apply voltage on the gate source, it creates electric field in the oxide layer. In n-channel MOSFET, the positive gate voltage attracts electrons towards the oxide and conducting channel between source and drain. And now explain about the n-channel MOSFET. And in the n-channel MOSFET, the electrons will attract to the source and current is generated, and that is similar to forward current, and that we use current VED and ID source. The ID source is increases. In p-channel MOSFET, we will have that in p-channel MOSFET a negative gate voltage attract holes. Same we can see in the bipolar BJT also same scenario, and here somewhat changes in this. And we apply the in p-channel MOSFET, a negative voltage attracts only the holes. Here you can understand that, and negative holes are attracted, and current is decreases, ID is decreases, and it acts as a reverse saturation. And we have a reverse saturation, and we will have a certain point that is called pinch voltage. Okay, now we will see about types of MOSFET. We have many types of two types of MOSFET. First one is depletion type MOSFET. This depletion type MOSFET match normally on at zero gate bias. Applying negative VGS and reduces current. Before I said that we apply when VGS and current is reduced, ID is reduced. In depletion type MOSFET, if the channel has even when the gate voltage is zero, if we apply the negative gate, it repels the electrons and reduces the current. That's why we will call depletion type, because the channel get depleted characters. The name comes from when depletion, it will deplete. I mean, it will not attract the electrons, it will repel the holes. And we have the second type of MOSFET, N-channel MOSFET. N-channel MOSFET normally off at a gate zero bias. Applying positive VGS includes N-channel and yellow currents. Enhancement MOSFET, because the channel is gate voltage, enhancement type MOSFET are the most commonly used in the digital ICs like CMO and technologies. Now we will see symbols and biasing. N-channel MOSFET arrows are pointed outward of electrons. Here we can see that NPN transistor and PNP transistor. We will see that arrow will be for NPN transistor, arrow will be outside. For PNP transistor, arrow will be inside. Outside means electrons, inside means holes. Biasing conditions. VGS controls the channel information and VDS drive the current from drain to source. Have to understand this carefully. And in N-channel MOSFET, arrow subtract outwards and showing electron direction. In P-channel MOSFET, arrow pointed inverted showing the holes. And VGS is the, I explained about this channel. Here we can see that channel forms only VGS is greater than VTH, and that is called threshold voltage. Now we will see the characteristics of MOSFET. We will have two characteristics. First one is transfer characteristic and drain characteristic. In the MOSFET, we will have only transfer characteristics. In these transfer characteristics, we shown between two relation between ID and mean drain current and VGS gate voltage. And there are three main operations: cutoff region, linear region, and saturation region. When we plot these curves, we note that the MOSFETs operates the three distinct points and cutoff region and linear region and saturation region. Each of these regions are corresponded to a different modes of operation, switching the various resistance or amplification. Now we will see the region of operation. Let us discuss about the three region in detail. First one is cutoff voltage. When VGS is greater than VGS is less than VTH, no channel formed, and the MOSFET acts as an open switch, and the drain current is almost zero. And now I will explain about the linear region. When VGS is greater than VDS, the small is small. The MOSFET behaves like a variable resistor. The drain current increases. Linearity VDS, the region in the analog circuits where MOSFETs are resistor and amplifier. Now we will say about the saturation region. When VDS, the drain current becomes constant, VDS is greater than VGS minus VTH, it will become constant and it is independent of VDS. The region is used to amplification and in the current source. Now we will see the MOSFET equations. For drain current in saturation, ID equal to 1 by 2 into K into VGS minus VTH whole square, where K equal to mu n into Cox CO X into W by L. Drain current in linear region is ID equal to K into VGS minus VTH into VDS minus VDS whole square by 2. And these are the fundamental in the circuit and analysis. Advantages of MOSFET. We have more advantages of MOSFET: high input impedance, lower power consumption, and compact size and suitable IC fabrications, fast switching speed, and compatible CMOS technology. And the applications of MOSFETs are here we have lower applications used in analog amplifiers, digital switching devices. Power MOSFET is converted in converters and inverters and SMPS. Core elements like VLSA and CMOS technologies used in memory device, signal modulation, and microprocessors, etc. Conclusion: MOSFET is the backbone of modern electronics, operates high speed efficiency at low power, and MOSFET is very essential in ECE and VLSA engineering. And this is about my seminar, and this is about my MOSFET.